Hello, everyone, and welcome to NTA302. This session is How Abrigo Transformed Its Business with AWS and Lessons Learned in the Process. My name is Jason Perlowitz. I'm the Vice President of Cloud Operations at Abrigo. I'll be joined today by Phil Schoen, who's a Senior Software Architect at Abrigo, and Nayan Karamuri, who's a Senior Solutions Architect at AWS. So thank you all for coming again. Hope you find the content useful. So today, we're going to just talk about our migration journey, our journey through optimization, and our follow-on journey, which is still in progress, of modernization. But before we get to that, we're going to set context. Talk a little bit about Abrigo's business, right, so that you understand where we came from, how we got to where we are, and where we're going next. So who's Abrigo, right? That's a name that not many people outside of the financial services industry have really heard of. Well, we provide market-leading compliance, credit risk, and lending software solutions to our customers. It allows them to fight financial crime, prevent fraud, process loans more quickly, and ultimately leverage a plethora of data that allows them to strengthen their portfolios. We've been in business for a little over 20 years, right? So we've been built over that course of time through various means. Some of it merger and acquisition, some of it in-house development and innovation, and through external partnerships, right? We've contracted some stuff out over the course of time. Our customers are community financial institutions. So they're banks, they're credit unions that live in your community. They're not the JP Morgans or the Wells Fargos of the world, right? But they're your named homegrown community banks, right? And we have 2,400 of them as our customers, right? And there's about 9,000 of them in the United States. So a very significant portion of the market share. So what did our environment look like 2 years ago before we started on our journey into AWS? Well, we were data center hosted, right? So we provided SaaS solutions to our customers. We used 2 data centers. They were geographically dispersed, one on the East Coast, one on the West Coast. Our East Coast data center was primarily used as our production side of things, and our West Coast data center was primarily used for disaster recovery, as well as for hosting a lot of our internal tools for development, quality assurance, and things like that. What did our infrastructure look like? Well, all in, it was about 1,500 total servers virtualized, and about 5 petabytes of total data under storage. So a fairly significant footprint. Now, our infrastructure is largely built on the Windows stack, 3-tiered type of architecture. Microsoft Windows as an operating system, Microsoft SQL Server of various flavors as kind of the relational database, at the next layer down, IIS as our application server, and built on a software stack of some legacy .NET and some more modern .NET. So kind of a hodgepodge that's all over the place. Right? And you'll see that's one of the challenges that we faced as part of this migration. While operating in our data center, we had about $7.5 million of annual capitalized spend to make all of this work. So that includes hardware, right? That includes the core licenses to operate that hardware, et cetera, et cetera. And as you'll see, one of our goals was ultimately to reduce that cost. And in these data centers, providing to our customers, we had 50-plus unique applications. All of them are SaaS, but they were all unicorns. And that was one of the challenges that we faced with this. It wasn't the number of applications, it was the uniqueness of the applications. So 2 years ago, as we kind of started the process of thinking about how do we get to cloud and what is our end game, we set a bunch of goals for ourselves, right? What were the outcomes that we ultimately wanted to achieve by getting to the cloud and by modernizing in the cloud? And they really fell into 4 separate areas. So the first of those was, as I mentioned before, cost savings. We thought that in the long run, we could save money by operating in the cloud. So we set target goals for ourselves. Number 1, infrastructure cost reduction. We wanted to be at least 20%. Now, we thought more than that was possible, right, in the long term, once we started to operate efficiently. But, it was a huge driver for us. Second, we wanted to tie our cloud spend to the growth of our business and as a healthy function of our recurring revenue. Our target goal there was 3.5%. Now, you'll see in the industry, some are 2%, some are 7%. That's kind of like a core range that we typically see. We wanted to be on the lower end of that. Second thing, operational resilience, right? We wanted to see improvements there. So, the best laid plans of mice and men sometimes go awry, right? You have incidents, right? No matter how well you're architected, no matter how much you try and avoid. We wanted to see our total incident resolution time reduce by at least 20% as a result of migrating to the cloud. And our total downtime, right? We wanted to see it reduced by 30%. So again, lofty goals. On the other side, business agility, right? So how do we bring our products to market? How quickly? And how frequently? So we wanted to see our deployment time ultimately be reduced by 25%, and our deployment frequency increased by 30%. And finally, we wanted to free up our smart people, our staff, to do smart things, rather than just kind of keep the lights on activities that are, a little bit mundane, a little bit rudimentary. We want them to innovate, right? That's where we get value from their time. We wanted to see their time spent on growth activities increase by 25% or more. So setting that as context, right, will help you understand some of the steps that we took along our migration, optimization, and modernization journey. So now I'm going to move forward and talk a little bit about migration. So what were the drivers for us to migrate to cloud? So first, we wanted to create accelerating momentum, migrating AWS, but do it with do no harm. We wanted our customers to have at least as good of an experience operating in AWS as they did in our data centers, if not better. And we wanted to do it without disrupting our customers, right? No unplanned downtime. Now, obviously, we had to take things off for a little bit, on the weekends, but our customers are okay with that, being in the banking industry. But outside of that, we want it to be seamless for them. We wanted to reduce the amount of manual work that we had to do and create automation that ultimately supported our migration process. The more you do things by hand, the more prone it is to errors, right? And we wanted to avoid that. And let's face it, even though we had 50 disparate applications, there's a lot of commonality that when you dig underneath the hood, that's rinse and repeat and rinse and repeat and rinse and repeat. Well, we don't want to keep rinsing and repeating manually. Ultimately, we wanted to build a foundation, right, that allows us to be successful in the future, right? So whether that's modernizing infrastructure, product, databases, what have you, right? We thought about that from the beginning, right? We thought about our end state from the beginning. And we wanted to advance our business and drive down costs. We wanted to equip our teams to be functionally literate in the cloud, right? We came from a data center environment. They're not the same, right? There's some common things, but there's also a lot that's a different way of thinking, right? A different way of doing, right? So we wanted to improve our own internal capabilities to operate in the cloud, and ultimately we wanted to also increase our overall security posture, right? As you can imagine, being in the financial services industry, we contain a lot of very sensitive data, right? It's of the utmost importance, right? It's table stakes for us to protect that data to the best of our abilities. From the get-go, we took an IAC, infrastructure as code only approach, right? So anything that was going in the cloud, it had to have infrastructure as code behind it, so it was reproducible. It was a core tenet for us from the very beginning of this project. And we want to take and leverage, industry best DevSecOps practices. And finally, as I said before, we want to increase our ability and agility to innovate and adopt new technologies more quickly. You've heard a lot at reInvent this year about AI, right? Well, we wouldn't be able to adopt that as quickly and move it into our ecosystem had we not been in the cloud, right? So proof's in the pudding, right? I think we moved at the right time, and that's one of the key drivers for us to move. Well, that's all great, but that doesn't mean that everything is cookie cutter and easy. We had challenges, right? So number one, as I said before, we had 50 unicorns. There weren't any standard operational patterns with these applications. Each one was different. That's partly because of the way we were built, right? You acquire something, it was built a certain way. You have a contractor build something, it's built a certain way, right? So, a lot of that starts to catch up with you in this environment and needs to be addressed and changes the way that you go and migrate things. We were time-driven. We had contracts with our data center where we needed to be out of our data center by a deadline. From inception to conclusion, we needed to migrate in under 16 months, all 1,500 servers. So that influenced some of the choices that we made. We were burdened by a historical lack of hygiene and large data volumes. Stuff builds up over the course of time, and people don't go and delete it when they should, right? So it's a burden, right? It slows you down. Tech debt, everyone has it. We had our share, right? But tech debt's an inhibitor as you go through the process, right? So you have to face some of those technical challenges head on. And then with our customer base, right, they have expectations and they need to be able to run their business. And as I said, do no harm. We needed to have strict downtime limitations where we could actually do our work. And we had to sandwich things in to fit into those tight windows, right, to minimize our customer impact. So let's now talk a little bit about solutions, right? How do we go and address these things? Number one, good houses are built on good foundations, right? And our journey started with collaboration with AWS Professional Services and Cornerstone Consulting, who's an AWS partner, to build our house on a solid foundation. And that took the first 3 months of this journey, right? It was all about building landing zones, right? Setting up the architecture, defining tagging strategies, right? Things that take time, but are going to serve you well in the long run, rather than not thinking about them up front and having to redo them later. Figuring out our security posture. So, as I said, we were also a data center company. We had to do significant investment in upskilling and training our Abrigo teams how to operate in the cloud, how to be effective, right? So there was a learning curve, right? That was also part of the reason that we leveraged AWS Professional Services, right, to help blunt that learning curve for Abrigo. But we had to make the investment, right, so that today, right, our team is highly effective operating in the cloud. Culture of the future. And what do I mean by that? Well, you can say that we did this a certain way historically, and it worked. And that might be true. That doesn't mean that you don't have to have a culture shift in your head to say, there's a different way to do it in the cloud. There's a different way, or a better way in some cases, to do it that is more future-proof, right? And so you have to have open-mindedness to be different and to go into uncharted territories, right? So we had to work within our teams to adopt a new culture. Many people have heard of lift and shift, right? So you byte for byte copy things across the network, and what you get at the input is what you get at the output. We coined a slightly different term, lift and shine. So basically it's lift and shift, but we took opportunistic times where we could shift something, right? And there was minimal effort to do so and get an outsized advantage by doing that. So let me give you an example. So operating systems. We had a myriad of different Windows versions. We took this as an opportunity to consolidate all of those so we were all at a standard starting place. Not a lot of work to do that. It added a little bit to our migration windows, but for positive benefit in the long term. So lift and shine. We also took this as an opportunity to eliminate unneeded environments and data, right? So I said we didn't have good hygiene, right? We took this as an opportunity head on to improve our overall hygiene and start from a good place. Bidirectional storage layer synchronization, right? So, 5 petabytes of data. Well, we had it all synced both directions, not only from our data centers to AWS. You'll see why in a second, right? It's so we have a backout path. Trying to take these 50 disparate applications and extract common engineering patterns, right? I said they're a little all over the place. That doesn't mean that you can't come up with an abstract, a common way to solve common problems, right? So what's our database architecture look like in a multi-region type of solution? It's a common thing for production for us. So we had to figure out how do we get from all of these disparate point A's to a common way of approaching that in AWS. And we took the opportunity to do that. We took the opportunity to do that at the storage layer as well. And finally, once we migrated, as I said, we were still in the process of migrating more stuff. We still had upskilling to do. We leveraged AWS managed services basically as a crutch, as a support crutch for us, right? For the first 6 months after we got done migrating. They helped us operationally support our systems until we were truly ready to own them ourselves. Migration techniques. So we leveraged AWS Cloud Migration Factory fundamentally as a solution for, setting up our wave plans and agent installation on all of our various resources and doing tag management at scale. It was an invaluable tool for us. We did real-time replication for our on-premise applications to AWS using AWS Server Migration Service, Application Migration Service, and then we also cost, right? Cost is a big deal, right? We said it was one of our core goals at the beginning. Well, we used Migration Evaluator to help us figure out and right-size our AWS instances, both before we migrated, like this is what we think it's going to cost, but then afterwards doing the necessary of constant real-time reevaluation to be sure that we hit the nail on the head and we were operating as efficiently as possible. And finally, we changed our approach to disaster recovery. So we eliminated about 600 instances. We started to leverage AWS disaster recovery services for those instances instead. A much cheaper solution, as you'll see, we saved about 70% on that set of instances by taking this approach, right? And you know what? It's faster for us, right? So adopting new technology where it makes sense, right, and where it's easy to do. So what were the outcomes of this migration? Well, I talked about incident response before. Year over year, since we've been in the cloud, our mean time to recover is decreased by 63%. Our mean time to acknowledge an instance has decreased by 56%. And our mean time to detect incidents has decreased by 22%. The total number of customer incidents has decreased by 72% year over year. And we didn't make fundamental architectural changes. The cost of our infrastructure right now is operating at 3.65% of our recurring revenue. This is down from just over 5% when we started. And lastly, performance, right? We talked about doing no harm. Well, again, this varies a little bit from application to application, but we saw between 15 and 30% performance improvement on average with various applications that our customers experienced directly. So direct customer benefit. And we completed that journey in only 13 months of the 16 that we had. Other outcomes. We talked about the business agility. Our time to market for new applications in the cloud is 70% faster than it would have been doing the same thing in the data center. And we just came out with one late last year, right? DR, I said before, we saved 70% by doing it this way. Technical debt. We've taken 50% of our overall technical debt out of our system. Now, we're not technical debt free. The world continues to evolve, right? So, it starts to build back up. But this was a major win for us, right? Operating a lot more modern by leveraging AWS services where we could, and by hitting head on the things that we needed to change or that we could opportunistically change when we had the opportunity. So before I pass it on, I want to leave you with just the things that they don't write in the book. So this is my 4th migration at scale with various companies, right? So I've done everything from 15,000 servers down to 1,500 servers. And there's a few things that they don't teach you, right? So I thought I'd leave you with Jason's tips and trips learned through the School of Hard Knocks. So 1, pre-cutover. There isn't a substitute for planning, right? Take the time up front. Plan what you're going to do. Replan if you need to, right? An ounce of prevention is worth a pound of cure. Next, typically we go from lower level environments to upper level environments, right? As we migrate and do the lower level environments first, dev, QA, UAT, staging. So if you experience a pain point or a learning in your lower level environment, do not proceed with production until you've corrected it, right? Don't shoot yourself in the foot twice. Like, it's simple stuff, but it's invaluable. I know sometimes you're time driven and you want to go fast. Take a pause, right? Do the right thing. Tagging strategy, do it up front. Figure out governance, figure out what's important to tag to get your business needs met with that information at a later point in time, it's easier to do it first than it is to retrofit it later. During the cutover, do a dry run of your production cutover first. We took a weekend, and we actually cut over production, and then we cut it back over to the data center and let it soak for a while. And our actual production migration was a few weeks later. You know what? The very first time we did this, we would not have been successful with our largest production migration had we not done that. It gave us 3 weeks to learn and correct. It also validated our backup plan, which is the next point here. Like, have a backup plan. Do not just intend to fix forward. Know that you can always fix backwards too, right, as an option of last resort. In your cutover windows, give yourself a buffer of time, right? If you think it's going to take 2 hours, give yourself 3 hours, right? You will hit something on the day of, right? Don't time constrain yourself. You know, I know we're in a world of remote work, and that's fine, but being together in a room, right, people of various disciplines, like, it's easier to collaborate, it's quicker to solve problems, right? At least until you get the hang of it, until you're a well-oiled machine. And finally, post-cutover, hypercare period, have one. So, you know, eyes on glass for the first week. Be super receptive to information that's coming in and work to address it right away. Start your FinOps practice day one, right? Cost becomes a big deal, especially in a lift and shine model, right? You're not always operating efficiently. So understand your costs and work to optimize as quickly thereafter as possible. And finally, you know, cost advantage savings, right? Use your savings plans and reserved instances early, right? Don't overcommit yourself, but minimally commit yourself where it makes sense. So that's all I've got. I'm going to turn it over to Nayan now, who's going to talk about what happened after our migration and our optimization strategies.
Thank you, Jason. So after successful migration of data centers to AWS cloud, so once the lift and shift was completed, so Abrigo embarked on a journey towards modernization. So before modernization, the lift and shine, and after lift and shift comes the optimization phase. So I've been working closely with Abrigo for more than 18 months now, and been part of migration modernization journeys. So today, I'm going to cover some of the challenges we had after migrating the entire infrastructure to AWS that Abrigo faced, and how some of the optimization mechanisms address those issues and helped us to create a platform that's ready for modernization. So I'm Nayan Karumuri, Senior Solutions Architect with AWS. To start with the optimization, the initial challenges Abrigo had was bubble cost. And it's mainly due to some of the resource inefficiencies, and it often accompanies a lift and shift when we are looking at 1,500 production applications migrating to the cloud. And some of the instances were over-provisioned just to avoid performance degradation, and also have a good user experience. Also, we hadn't yet transitioned to a fully optimized auto-scaling or reserved capacity models, right? And the second one is cultural resistance to change within the organization. It emerged as an obstacle at initial phases because team just started adopting services or practices like immutable infrastructure as a code, auto-scaling, things around those lines. And some of the teams were comfortable with legacy VMware workloads, and which initially hindered some of the efforts to adopt serverless and containerized workloads. Right sizing and performance tuning were more challenging than expected due to seasonal workload variability. So the initial resource planning was always based upon the peak usage patterns, but after some time, the workload started running on AWS. We have seen a cyclical seasonal patterns in mission-critical applications. So we took help of some of AWS native services like CloudWatch Metrics, AWS Cost Explorer, to understand what was the actual consumption and what was the actual cost associated to the resource utilization. That helped us to it helped us to create a guide for the optimization for the next few months. The solutions, today I'm going to talk about some of cost optimization mechanisms that we implemented in place, especially seeing from the lens of well-architected framework. We'll start with compute optimization, and then storage optimization, and other cost-efficient mechanisms that have been implemented in the architecture that was running on AWS. And to start with, a significant optimization involved replatforming. So Abrigo moved some of their .NET applications from Windows to Linux environment, and utilized AWS Systems Manager and also CloudFormation to automate some of the replatforming tasks, right? And also transition from Red Hat Enterprise Linux to Amazon Linux. So this is not only a cost-effective solution, but it helped us to seamlessly integrate with AWS Cloud Native Services. And also it opened the door to utilize the Spot instances wherever possible, for example, for non-production environments like development and test, where they can reserve more compute capacity for unused EC2 compute capacity for a lower price. To start with optimization techniques, compute, whenever we talk about compute, we start with sizing the instances and also selecting the instant type that fits our workload. For example, Abrigo has some AI, ML workloads and real-time analytics, which required higher CPU to memory ratio. So in that instance, we right-size those instances to compute heavy C-type instances. And there were some applications, for example, fraud detection, which required more memory capacity compared to processing unit. In that scenario, we were leveraging R6 type instances, which provided 25% more I/O. And then migrated legacy M4 CR instances to Graviton, which is AWS custom-built ARM-based processors, and which provided additional 40% improvement in performance compared to the traditional x86 Intel or AMD-based processors. And then stateless fault-tolerant workloads. So there were a set of applications, for example, batch processing, machine learning training models, where they are stateless in nature and they can take advantage of the Spot instant types. So again, 90% of cost savings by running those workloads on Spot instances. And then once we were able to identify right instance types and map them to each individual workload, depending upon the behavior of the workload. And then we also implemented additional optimization techniques, for example, FinOps automation with AWS Lambda. Right, so here we took off instance scheduler and leveraged AWS Lambda functions, which triggered by CloudWatch events. So it automatically shut down some of the instances during non-core hours. For example, non-critical resources like dev and test environments. And it provided an additional saving of 50 grand annually. And then thanks to AWS Cost Optimizer, so we were able to monitor compute utilization once the workload fully got migrated to AWS, and it provided more insights for right-sizing recommendations to Amazon EC2. So with help of Compute Optimizer, once the application started running on AWS, we identified around 247 EC2 instances where we further optimized for cost benefits and without compromising on performance. And then scaling policies, using right target tracking mechanisms based upon CloudWatch custom metrics, we were able to scale up and scale down resources dynamically. And the auto-scaling groups not only contained on-demand instances, but it was a combination of Spot instances as well, behaving depending upon the behavior of the workloads we have. And a lot of compute operations have been automated, for example, patching and backup with AWS Systems Manager. And Abrigo also migrated some of the container-based applications to Amazon ECS for further optimization with better performance. We're going to dive deep into the AWS Fargate in the modernization phase. And coming to the cost management, we had AWS budgets in place. This is, again, creating a FinOps practice for all the infrastructure that's running on AWS. So AWS budgets, we had a custom limits, thresholds based upon account type, team, and projects and applications that are running inside. And we had notification services to trigger alarms. And also we had AWS cost categories to organize the cost across the teams, departments, and as well as AWS accounts. So integrated cost anomaly detection, with help of cost and usage report, we were able to do granular tracking and identify if there are any applications that are behaving like crazy, like producing a lot of consumption on the billing side. So it helped us to identify the reason and how further we can optimize the application. And then reserved instances and savings plan. So today, Abrigo has auto-renewal scripts in place for any application that is steady state in nature and has a predictable workload. So they have logged in a lower rate with utilization monitoring at 99.5%. So if we are looking at a long-term cost savings, so having 85% of compute running on a savings plan or reserved instances is a big win. And also optimized cost efficiency by combining reserved instances with dynamic auto-scaling in place. So CloudWatch metrics, for example, monitors the CPU utilization, IOPS, throughput, and we have different metrics in place to dynamically auto-scale the EC2. And then comes the storage management. So starting from migrating or shifting from GP2 to GP3, there was a big requirement where we wanted to have a benchmark performance without depending upon the size of the volume, without depending upon the volume size. So GP3 provided 20% reduced cost without compromising on a performance, and it maintained the throughput to IOPS. And then FSx ONTAP is AWS managed file system built on top of NetApp ONTAP. So Abrigo optimized the read-write IOPS profile for some of their application storage systems. And they also implemented tailored caching mechanisms, right, for faster retrievals and adjusted tiering policies. For example, if there is high-performance data storing the data in SDD, if there is any archive data taking help of HDD. So it also helped us to meet the performance limitations at the same time having cost benefits. And S3 intelligent tiering reduced cost by 40% by moving data to lower storage tiers based upon how frequently the data is accessed. And how we identified the unused data and how we migrated to S3 Glacier is through our S3 storage lens. And further optimization, like as Jason mentioned before, the disaster recovery, lots of cost savings came from S3 standard IA and as well as Glacier Deep Archive. So lots of these backups which are not frequently accessed have been moved to lower storage tiers. Then coming back, shifting gears to the databases. So right now, transitioning to Amazon Aurora PostgreSQL will reduce further cost by 40% and also provides an improved scalability posture on AWS. And replacing some of commercial databases like MongoDB with DocumentDB will provide an additional reduction in management overhead as well. And Abrigo streamlined the backup management with AWS Backup, like, for example, automating snapshots or creating the retention policies in place. So it overall provided a streamlined service of maintaining and as well as creating a security posture for the backup policies. And then on the left-hand side, you see AWS Key Management Service, KMS. It's more like a thumb rule. Post-migration, Abrigo implemented a least privilege model. So this is achieved by auditing permissions using AWS Identity and Access Management Access Analyzer. So it pretty much maintained the security posture in terms of IAM policies, which user should have what restrictions and what limitations in place. And IAM Identity Center, like across all environment, it reduced the administrative overhead for access management. And Abrigo also optimized encryption of data at rest across EBS, S3 databases by using AWS KMS, and we also had custom key policies so that we always maintain that compliance in place. And the template modularization, AWS CloudFormation, as the first slide, we started with automating some of the migration tasks, right? When Abrigo started migrating compute instances to the cloud. So CloudFormation optimization, template modularization, it pretty much break down the large infrastructure as a code into smaller modules. So like you can call them as a nested stacks. So what happened here, we were able to, it was easier to update and reuse this stack whenever required. And also the parameter and output management, we were able to use parameters to customize the stack whenever it's required, ready for deployment. And output variables retrieve the values of the resources that has been deployed on top of AWS. So as a whole, it provided a flexibility and reusability across environments. Automated resource scaling, again, it connects back to the CloudWatch metrics and dynamic auto scaling policies we have in place to scale up and scale down based upon the traffic that we have in place. And CloudWatch log analytics helped us to identify the performance bottlenecks for different applications and databases. And it also opened doors where we can further optimize the environment on a given large scale. A quick snapshot of the outcomes of optimization. So we did start about right-sizing the EC2 instances and then selecting the right instance type based upon nature of workload. So EC2 optimization provided a 140 grand savings annual, and then 30% process generation upgrade provided a performance uplift. And Abrigo also had additional 250 grand of annual cost savings by optimizing both EBS and as well as FSX on-tap storage. And 85% savings on SPs and RA utilization, savings plan and reserved instance utilization, and also 60 grand annual cost savings for automated power cycling, where AWS Lambda worked in tandem with CloudWatch metrics to shut down some of the instances during core office hours, and also depending upon nature of the workload. So once this optimization phase has been successfully achieved, so Abrigo is now ready, to go all in for the modernization, where they started exploring more AWS native services for some of the projects, like ETL, glue data pipelines, or it might be moving from commercial databases to open source, or also containerizing their applications with ECS and Fargate. So now Phil is going to dive deep and take us through the modernization phase.
Thank you, Nayan. Hi, everybody. My name is Phil Schoen. I'm a senior software architect with Abrigo. I'm going to talk a little bit about modernization and our journey on it. One thing to keep in mind is we're pretty new to it, right? We're 7 months in. Jason talked us through that whole journey we went on. Coming from the app dev side, I was really excited about the new services and opportunities that the app dev team was going to have with all of the things that were available with AWS. As we talk through modernization, though, and before we hit these challenges, I'm going to kind of talk through broad, and then we're going to kind of zoom in on one of the particular aspects of modernization that I was personally a part of. Let's talk a little bit about the challenges, though. Tech debt. Jason touched on this. One of the tough parts about tech debt is, I heard somebody say, and I like it a lot, it depends on who you took the debt from, right? If you borrow money from grandma, maybe your debt's not too bad, but if you borrow money from a tech loan shark, you better get that money paid back. As we moved into AWS, some things started to change about what this tech debt looked like. So we're going to kind of touch on that. One of those things was that monolithic architecture. At first, it's very easy to move a monolithic architecture and deploy it, but as it grows, it starts getting expensive. There's some risk associated with it, so we need to kind of deal with it. The other piece that we had to kind of look at here was getting prioritization for working on these pieces that aren't directly tied to features. We're a software company. If we don't make features for our customers, they may not want to buy our software anymore. So we need to keep that going, right? But there's high value, right? If we invest in the architecture, if we invest and take the time to put together modernization, our app dev teams can go quickly, but it takes a little while to realize that. Here are some of the solutions that we've already started to utilize. Some of them we're figuring out how to utilize them and get better at using them. And I won't read all through them, but you can see some of the top hitters. What they really all boil down to for us, though, is scalability, standardization, high availability, right? Some of these things are tough to get in a data center. Reduce cost, both from licensing costs and just running less stuff because maybe scaling's better. And then operational efficiency. Here's some nice numbers, right? Some really good outcomes we've had already. When we look at DRS, these first two, right, $1 million savings, that comes from not having to run, being able to turn stuff off. DRS, we get those up faster. And I'll tell you, personally, being involved with some of these disaster recovery exercises, we try to do those regularly, right? Only one of our big products was able to do sort of a seamless disaster recovery without downtime to our customers. And because of what we were able to do with DRS and just use those basic tools, it unified it across all our other products. We were able to go in and have a standard operating procedure around those. The other areas here, Postgres, you can see big savings and just general operational overhead. Just, it takes less. And they can just scale. You can't touch it. We couldn't touch it. And it's been great. A lot of our greenfield products already, meaning products that are coming online now, our features, they're using Postgres RDS. The last thing, Babelfish. We're excited about how that is going to help our development teams not have to take so much development time in switching over. Let's talk a little bit about disaster recovery on the left here. Again, some nice percentages, right? I want to tell a quick little story about CrowdStrike. If you guys remember back in the summer, there was an incident, and we run a lot of Windows machines. And I still remember getting on the call that Friday, and we were out. Those machines were done. We couldn't get them booted. We couldn't flip over to safe mode, so we couldn't use DRS. We had to go to the backups. And because we were able to go to the backups, our ops team put together a fantastic automated script. And before the day was over, we were able to restore root volumes back to those devices. We had our production back up and running within about 6 hours. We would have never done that in our data center. Just wouldn't happen. Not that kind of time. It was kind of incredible, right? And we got that because of the move and the modernization we were already embracing. The next chart here, or the next bar here, patching compliance, just a real quick one, right? We were pretty good at patching, about 92% in our data center. Little spotty here and there, but once we moved into AWS and we took on their practices, we're at 99% patch rates. Fantastic. And their faster patch cycles, just great stuff. The serverless bar here, this is really talking to our ability for greenfield when we bring on new products. We are starting by looking at Lambdas, starting by looking at ECS, right? And we have already seen efficiencies right out of the gate, right? One of our new products that came online, fraud, it was our fraud product this summer. It has spotty traffic. And because of our use of Lambdas, we get to leverage all of that, right? We're not running EC2s all the time. We go down when we're not using them, and we come up when we do. And they've been able to handle those workloads nicely for us. Containers. This is where we're going to start digging a little bit in. I'm going to actually dig a little more on this with some charts. So a few spoilers to the last bit of what I'm going to talk about, container efficiencies. This chart on the left, the purple, if you can see that, hopefully you can see that, there's some dotted lines behind it. And what that chart on the left is trying to show is that essentially the charts on the right are apples to apples, meaning before we switched over to container workloads, these were our requests per minute. As soon as we switched over, that's the dark bars. So when we look at the chart on the right, you can see this is just the 50 percentile, so our averages, right? We can see a lot of bouncing around at higher rates, right? That's a combination of windows and some other things, but we get a nice smooth chart once we move. Interesting enough, when we bump up to the 95 percentile, you can see we start getting a little better even. And then when we go to absolute max, right? So I always like to do this when I'm looking at our stuff. How bad is it really? Like, because somebody feels this. It's not like it's just no big deal. And you can see we're at seconds in certain intervals now. And then all of a sudden, we flatline. So I got a little freaked out when I saw that, like, this is no good. But if you look at the chart there at the bottom, that is a zoomed in version of exactly what you're seeing at the top. And this was just our QA environment. I'm excited to tell you this held through all of our environments. It held all the way up to production, and we have this particular service in production right now, and the graphs look the same. So a big success story, very happy with it. Let's dive a little more and talk a little more about that particular service and what we did and why we did it, how we modernized it. First, let me set the stage a little bit. We talked about the monolith, we talked about tech debt. This is what that environment looks like. 20 production instances, 10 blue, 10 green. We run these EC2s. It's IaaS, .NET Framework, and we have dependencies on Active Directory. We have SSL certs that we have to install regularly, right? We don't want to allow any traffic, even between the load balancer and the boxes, to have any kind of lack of encryption. We have .NET logging agents installed on all of those boxes. The other thing that is important to kind of keep in mind is this stack is part of a monolithic release, meaning that this particular product was developed and can actually deploy its services independently, but it chooses to lock them together for release for testing purposes and things like that. Again, Jason kind of touched on some of these, the way they were growing up, and this was one of those. That blue-green helps us support zero downtime, so we needed to make sure that was a factor when we started taking a look at ECS. Now, the good part was we had at least 5 services that we had already ported to .NET 6, which, if you know your .NET Core became .NET 6, and now 8, and on to 9, wherever we're at now. So, why do we pick ECS Fargate? We actually picked Fargate specifically. It was kind of our Goldilocks. One, ECS scales, period, but 2, we knew we could do zero downtime deployments, but 3, it was very appealing to not have to deal with EC2 management, right? That was felt like a big win if we could make this happen. Some challenges. We talked about the certs, we talked about the logging, we talked about interacting with AD, and deployment pipelines. So our goal was kind of to reduce operational burden that we had and see if we could get the gains, right? Again, you saw some of the spoilers we did. Well, let's talk a little bit about a couple of the different pieces and how we dug into them. And again, what we did here was to address the certificate management. So this, again, was to help us with that distance between the load balancer and our active instances. So you can see here, working from left to right, as traffic comes in, we actually handled and created that blue-green strategy based on our tasks, our services within the ECS cluster. Next, we took those tasks, those services, and we spin up as many tasks as we need for that blue or for that green, right? So that allows us to switch between blue and green for that coordinated deployment I talked about. And then you can see here at the bottom right that those tasks reach out to Secrets Manager and reach out to Certificate Manager and create an encryption tunnel between that entire line we just drew. Now, we did this using a custom Envoy sidecar, and it's worked very well for us so far, right? This, again, removed the need to install that SSL cert on every box. By the way, it has to happen every year. It's coordinated. It's the little hassles, right, that just add up. Jason kind of mentioned. Let's take a look at another one, application logging. When we started digging at our options for logging for us, it boiled down to kind of two spaces. We could push everything to CloudWatch, or we could put an agent, a sidecar agent, using FluentD and FireLens, and pipe directly to New Relic, who is our logging agent. Some cases we do one, and the other case we do the other. Again, if we don't need it in CloudWatch for particular alerts, right, we don't need to take that hit, right? We can save the money and go straight there. So again, we use FireLens and FluentBit to accomplish that, and we've been very happy with that solution. Let's talk a little bit about AD, right? There were three options when we started digging in on AD, right? And when we started to explore, we went down all three of these paths. One is to just use Kerberos directly. The next is to go ahead and do a GMSA service set. And we did. We explored these all. Again, some great work by our friends at Cornerstone. But we came back and we just settled on simplicity, right? AD is a little bit of that tech debt for us, right? It means we can't auto-scale as fast as we want in some of the other cases. And the more we can work to get rid of that, the better. And it turned out this required very little in terms of how we grab that secret. And so our DBA folks were happy to kind of help us move these service accounts over to native accounts. And we used a combination of Secret Manager and some modifications we did in those ported apps I mentioned. And the last piece we kind of solved for was the deployment pipelines. Now, in this case, we wanted to support our emerging interest in GitHub Actions and their workflows. We have historically been on Octopus. It served us well, lots of visual aid there. And so we really wanted to support both. And we did that with the means of actually we put together a deployment container. So there's a container that can be called and used just for the deployment model, and it will actually go ahead and update the service and make that zero downtime swap out for us. So that's all I had to cover on our journey into ECS Fargate and a lot of the modernization. I really appreciate the time. Jason, Diane, and myself will be available off to the side. Thank you all for your time. Hope you have a great rest of the day.